Welcome back to Aurora Tech Channel. Today, I will be reviewing the Snapmaker Artisan printer, which is their latest 3-in-1 machine. I will test out all features by 3D printing with different materials, testing dual extruder printing, laser engraving and cutting different materials, as well as CNC engraving and cutting wood, acrylic, and aluminum. Let's take a look at the features. As this is a 3-in-1 machine, it comes with 3 tool heads and 3 beds. The tool head and bed are both modular designs. Switching from one to the other doesn't require the use of any screws. This lets you complete the switching process within a minute. The motion system uses a linear guide with a stepper motor and timing belt, and everything is enclosed in a module. The machine has an all-metal structure, so it is super heavy and rigid. There's also an external control box which comes with a 7-inch touchscreen and an emergency stop button. The machine also has a huge enclosure with LED lights, a door sensor, exhaust fan inducting, and laser-safe acrylic boards on all 5 sides. The working area of this machine is a 400mm cube. As a 3D printer, it comes with a dual high-temperature print head that can reach up to 300 degrees Celsius. The heated bed can be heated in 2 different zones. For smaller prints, you can just heat up the inner zone of the bed to up to 110 degrees Celsius, or heat up the outer zone up to 80 degrees Celsius for larger prints. As a laser engraver, it comes with a 10-watt diode laser module. It has an autofocus feature to detect the thickness of the material, as well as a built-in camera for material alignment. As a CNC machine, there is a 200-watt spindle with a maximum of 18,000 RPM. Snapmaker only advertises that their CNC can work with wood, acrylic, and other more soft materials, but with a rigid frame like this, it should be able to cut metal as well. I will find this out for sure when I test some aluminum cutting. I would like to thank Snapmaker for sending me this machine to review, and with that, let's get started. The machine came in 2 large boxes, each of which has many smaller boxes inside. As you can see, all of these boxes take up my entire 30-inch by 6-foot table. They're clearly labeled, so when you follow the user manual to put everything together, it's pretty easy to locate any parts that you need. First, flip the Y-axis upside down and use the foam that came with the machine for alignment. We will put the base on top of the foam. The base is all metal, and the part that needs to be connected with the motion system is CNC machined. Tighten all the screws to secure the base to the Y-axis and flip it over. Now, we can put the X-axis mounting plate on the Z-axis and then use the mount to connect the Z-axis to the base. Do the same to the other side and tighten all the screws. We can now turn it over and install the X-axis on the mounting plate on the Z-axis. Then, tighten the 4 screws from behind. Next, we will mount some cable clips onto the frame and let the X-axis and tool head cable run through them. Then, install the tool head mounting plate, and I'll just put on the 3D printer tool head first. Mount the frame for the bed on the Y-axis and secure the print bed to the frame. I will just test this printer without using the enclosure, as it may take a while to put that huge thing together. After that, we can connect some cables. The cables for the X, Y, and Z axis, the tool head, and the heated bed are all clearly labeled. Finally, I will install 2 spool holders at the top and turn on the machine. Let's start with the setup wizard on the touch screen. Select the language, agree to whatever it says, select your own Wi-Fi network, and we can now follow the touchscreen instructions to load some filament. Filament must be loaded in both the primary and secondary extruder, as the machine will run an XY offset calibration after this. It will now perform a Z height calibration for both extruders, followed by auto bed leveling. It uses a strain gauge to measure the pressure when using the nozzle to probe the bed. It will now print two rulers, one for the x-axis and one for the y-axis. We will use these prints to check the current offset settings. Select which line is aligned best on the x-axis, followed by the same thing for the y-axis. Now the calibration is complete, and the machine will print a test model. It looks like the x-axis is still a little bit off, so I will run the test one more time later to calibrate it again. Okay, let's start our test prints with the 3D Benchy using ARRI1 PLA. Since this printer claims to be able to print at 200 mm per second with 20,000 mm per second squared in acceleration, I will print one at a 0.2 mm layer height at a speed of 100 mm per second. Inside the workspace, the Snapmaker machine is here, so select Connect. If we select Start on Luban, it will send the job and start it right away on the printer, and also continue monitoring the print job in this workspace. If we select Send to Device, it will just upload the file, and we need to start the job on the touch screen. This Benchy took an hour to finish, which is pretty good. It seems that printing at this speed is no different from other printers that print at 50 mm per second, as a standard Ender 3S1 printing at 50 mm per second with a 500 mm per second squared acceleration requires 1 hour and 46 minutes to print this Benchy. I will print one more with the fast mode. The speed is 160 mm per second and the layer height is 0.24 mm. This took 49 minutes to finish, and the quality is still not bad. It has a bit more stringing than the normal 1 hour one, but the cooling is okay, and I didn't see a significant quality decrease on this 49-minute Benchy. Next, I will print a Jeep, and I'll enlarge the model to 150%. The Artisan only took 9 hours and 37 minutes to finish, and the print quality is pretty good. The wheels can move freely, and all the details look really nice. Then, I'll print a robot hand using Voxel PLA Pro. I will use a medium height of 0.16 mm and a fast speed of 160 mm per second. It took less than 3 hours to finish, and the hand is fully functional as I can pull the fingers and make it move. Afterwards, I will print a dual-color truck by assigning each model to a separate extruder and aligning them using Luban's Align feature, similar to Cura's Merge feature. Although dual extruder printing may not be as clean as single extruder printing, the print finished well enough, and the part can move freely with adequate clearance. Up next, I will try some breakaway support filament. I will print this dragon model using the 2 rolls of filament that came with the machine, black PLA and the breakaway support filament. Let's see how this breakaway filament works. I've printed this dragon model before with different printers and different PLA filament. The hardest part to remove has always been the support inside the mouth, so this is the first time I've ever noticed a tongue inside the mouth. The previous models may have had the tongue removed alongside the support. The details in this print are really nice. Then, I will print a screw box with Area 1 PETG. As you can see, the corner is slightly warped. Since the temperature in my garage is only around 15 to 16 degrees Celsius during the day and 10 to 12 degrees Celsius at night, the bed sticks perfectly fine to PLA, but I may need to apply some glue to print PETG successfully. For the lid of the screw box, I will try to print it with Area 1 TPU. As TPU always sticks well, it shouldn't be a problem even in my cold garage. This print looks perfect and fits perfectly on the screw box. After that, I will assemble the enclosure. The process is straightforward. Form the base with 4 25 by 25 extrusions, slide in the 2 acrylic panels at the side, followed by the top. However, it actually took me even more time than putting the machine together since the enclosure is so big, and it felt more like building a house. The good thing is that I could just go straight inside to connect the cables. Now that it's fully enclosed, the machine looks even nicer and more premium. With the enclosure, I will now try printing ABS. I honestly don't expect it to help much with maintaining the ambient temperature inside. My first attempt was to print directly on the bed, but as expected, it came off before the print finished. When I tried applying my forever favorite Elmer's Craft Bond Extra Strength glue, the print finished without any issues. My garage is only around 11.5 degrees Celsius at night, but with the printer enclosed, the temperature can be increased by 10 to 12 degrees. This may also be affected by the exhaust fan since I'm printing with ABS, so I turned it on to exhaust the air outside. The print stuck so well to the glue that it had a perfect bottom. The white marks on the bottom can just be removed with warm water. Since this is a high-temperature extruder, I will try printing with some engineering-grade filament. I will print this blink camera mount with Prusa PC filament, and with glue applied, the print was completely successful. Now, we will transform this machine into a laser engraver. Just unplug one cable, slide off the print head, slide on the laser tool head, secure it with the lever, and connect the cable. To change the bed, unlock the lever, unplug the heated bed cable, put on the aluminum bed for laser engraving, secure it with the lever, and we're all set. I will start with a sample project of a protractor and ruler. Since my MDF board is small and is only around 150 by 200 millimeters, I will turn on the camera and use the picture of the print bed as the background for alignment. I'll then move the parts to the MDF and they should fit just right. I will just follow their default parameters for MDF. It starts with engraving, and after that, it will cut the part out. As you can see, the laser light penetrates through the board, and you can see the blue light on the bottom of the aluminum bed. The whole process took just around 5 minutes. The lines are all clear, and the part cut through completely, even these tiny circles. Then, I would try to cut some thicker wood. I will use this 1/4 inch or 6.35mm thick poplar wood that I bought from Home Depot. For my first attempt, I will use 100% power at 200mm per minute. It almost cut through, but there is still a tiny bit of wood at the bottom that is connecting the two parts together, so I would try to cut the letter A at 150mm per second with the same 100% power. This time, the letter as well as the small triangle in the middle were both cut through completely. The cut is still pretty clean, as this model has a strong fan that blows air from the nozzle. It's not as strong as a dedicated air assist pump, but it still gets the job done with pretty good results. Next, I will try some photo engraving. I will just use the default parameters in the software, which sets the speed to 800mm per minute and the power to 25%. This is much slower than what I would normally use, but using a slower speed and power usually generates better results. So let's see if this is the case this time. This 120 by 100mm picture using a 0.25mm fill interval took 90 minutes to complete, which is a long time, but it looks really nice and the details are awesome. Finally, let's transform this machine into a CNC. Switch it to the MDF foil board and secure it with the lever. Then, slide the laser tool head off the plate and slide the CNC spindle tool head back on. Let's start with some wood engraving by installing the 20-degree engraving bit that came with the machine. We will use the 2 wrenches to tighten it, and then we will be ready to go. I will start with this Harry Potter Gryffindor house logo, engraving it 2mm deep and using a 1mm step down to run 2 passes. This operation will take 14 minutes. The toolpath preview on the workspace also looks good to me, so we can just start the job. The engraving on this walnut board is beautiful, and I will now change to another double flute end mill to run a contour to cut the logo out. As the wood is a 1/4 inch thick, I will cut it deep down to 6.5mm and use a 1mm step down. This operation will take 18 minutes. The toolpath preview in the workspace looks good, so we can now start the job. The board cut through completely, but the top and bottom surfaces are not very clean, so I took another 3 minutes to use a 220 sandpaper to sand it down. The result still looks pretty good, and the edges are all clean now. Then, I will make the same logo on a 3mm acrylic sheet, starting with the engraving. For acrylic, I will engrave 0.3mm depth in one pass. Afterwards, I will use the other single flute flat end mill that came from the machine to run a contour and cut down 3.5mm at 1000mm per minute with a 1mm step down. It will run 4 passes to cut it out. The acrylic looks even better than the walnut wood board, and the edges are also clean. Lastly, even though Snapmaker didn't advertise this machine as being able to cut aluminum, I still want to give it a try because of how rigid the machine is. I will start with a conservative cut running at 100mm per minute with a 0.1mm step down. It's super slow, but I can't feel any vibrations at all and the cut is very clean, so I'll try pushing this machine much harder. Next, I will try a 0.2mm step down, and the machine still handles it pretty well, so I will try a 0.3mm step down. Nothing breaks and everything is fine, so I will try a 0.4mm step down. It's not as clean as the other cuts, so I will try a 0.5mm step down and see what happens. The chips are flying and it looks good, but the sound of the end mill is telling me it's really close to its limit. Let's take a look at the result. 0.1mm is perfect with a mirror finish, while 0.2mm and 0.3mm are still not bad, but 0.4 and 0.5mm are a bit rough. Now that I know the machine can mill aluminum, I will use a speed of 100mm per minute and 0.1mm step down to make a wrench. I would try to make it as perfect as possible by using the slowest speed. However, it's going to take 2 hours this way, and I don't have that much patience to wait so long for just one simple wrench. So, I would try using 150mm per minute and a 0.15mm step down. Okay, 54 minutes is more acceptable. Let's see what kind of result we can get. The machine completely cuts out the wrench from this 1/8 inch aluminum stock, and the cut is pretty clean. The chip size is not that big, but it's much better than 0.1mm step down aluminum dust. The wrench actually looks great with clean edges. It's still not bad compared to the wrench that came with the machine, and so I'm fairly happy with the result. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The build is super high quality. The motion system on all X, dual Y, and dual Z axes is rigid. The whole frame is metal, and the control box, touchscreen, and even the enclosure are all well made. 2. Switching between tool heads and beds is fast and handy. You don't need to tighten a single screw, just slide one out and slide another one in. The entire process should probably take less than 1 minute. 3. When working as a 3D printer, the print is high quality, the speed is fast, and it can print a Benchy in 49 minutes with good quality. It is in line or even faster than those so-called 250mm per second bed slingers in the market. I tested PLA, PLA Pro, PETG, ABS, TPU, and high temperature polycarbonate on this printer, and it prints well with almost any material. The dual extruder design is similar to Ultimaker, but they make it even better than the Ultimaker. It uses another set of motors inside the hot end to raise or lower the print head, unlike Ultimaker and many similar printers that move the print head to bump something to trigger a lever to adjust the height of the print head. 4. When working as a laser engraver, the 10-watt module is also in line with other 10-watt modules. The photo engraving result is pretty nice, but it's not super strong in cutting. Still, it can cut 1/4-inch solid wood in a single pass at 150 mm per minute and 100% power. The auto material height detect feature is also really handy. I didn't have to manually move the laser head for materials at different heights or enter the thickness of the material in the software. Everything was done automatically. 5. When working as a CNC machine, the 200-watt spindle combined with this super rigid frame work pretty well. It can cut not only wood, acrylic, and the other soft materials as advertised, but when I tested by cutting slots on a 6061 aluminum plate, I could push it to a 0.5mm step down. When making a real part, I used 150 mm per minute and a 0.15 step down. The result is good, and the part is fully functional. 6. Snapmaker polished their machine really well. Other than the high-quality hardware, the user manual is also one of the best I've seen. It's a Prusa-grade documentation. This machine has exceeded my expectations, but there are still some minor issues that Snapmaker can address. So now for the cons. 1. As the hot end is a high-temperature hot end, but this printer doesn't come with a hardened steel nozzle, you need to purchase another high-temperature print head separately. But the price of the parts is still reasonable. For a modular hot end like this, charging around $50 is fair, unlike my Ultimaker S3, where buying a modular hot end that is much simpler than this one costs $300. 2. The Luban software is pretty user-friendly, and all of its features are usable. During my tests, I used the Luban software for 3D printing, laser engraving, and CNC milling. But there is still some room for improvement. For example, when slicing complex or larger models, it takes longer than Cura. For instance, when I sliced the enlarged 150% Jeep model, Cura only took 13 seconds to slice, but Luban took almost 1 minute. For laser engraving, the default speed is also set to 800 mm per minute, which is quite slow. Engraving a 120 by 100 mm photo using a 0.2 mm fill interval will take 2 hours. However, when I tried to increase the speed to 5,000 mm per minute, it showed a job time that was only a few minutes faster. I'm not sure whether the software or the machine firmware is limiting the maximum speed for laser engraving. I did report this to Snapmaker, and they said they're working on it and will release an updated firmware version soon. 3. The enclosure itself is high quality and rigid, but after engraving and CNC cutting, you may need to clean it. It is pretty easy to clean the front by opening the door, but I can't find any way to access the back unless I unscrew the back panel, detach it from the machine, and remove all the cables. It would be nicer to move the cable and ducting cutout to the right side panel, as Snapmaker recommends placing the control box on the right side of the machine. Therefore, the back panel could be another door or have a magnetic removable design to make it more accessible. Another thing is, as the enclosure is so huge, it doesn't help much with keeping the ambient temperature when 3D printing, especially if you turn on the exhaust fan when printing ABS or other materials that require good ventilation. My garage is pretty cold at night, around 11 to 12 degrees Celsius. Using the enclosure with the exhaust fan on to print ABS can raise the temperature by about 10 degrees. I can successfully print ABS mainly because of the PEI print bed and the Elmer's Craft Bond extra strength glue. In conclusion, Snapmaker did an excellent job of combining 3 high-end machines into one. The hardware is almost perfect and the details are well polished. The Luban software is not perfect, but it's fully functional. With the modular tool head and quick swap bed, switching from one to another can be done within a minute or less. If you have limited space and are not able to fit 3 machines into your workplace, the Snapmaker Artisan would be an excellent choice. But if you're using it in a shop and need to do 3D printing, laser engraving, and CNC frequently at the same time, buying 3 different machines is the better option. Of course, buying 3 different high-end fully enclosed machines of the same quality would cost you much more. If you are interested in the Snapmaker Artisan 3-in-1 machine, I included the links in the description. If you found this video useful, please consider liking and subscribing to our channel. Thank you for watching, and I will see you next time. However, when I tried to increase the speed to 5,000 milliliter, I will test out all features like 3D printing with as this is a 3-in-1 machine. It comes with 3. Okay, let's talk. I don't have my mic on.